Hello viewers, welcome to my foundational video on directed numbers with a bit of algebra, right? And laws of indices. The cases that we're going to solve is just 4 of them, and then you are welcomed to skip if you are quite good with directed numbers and laws of indices. Why am I covering these basics? Because they form a strong foundation for tools like factorization. So without spending much of the time, let's get into it. Let us solve 7x plus 9x using a bit of illustration. Imagine you're in an elevator, right? Going up, we are going to the top floors or to the positive numbers. Going down, we are going to the negative numbers. Now, another way of visualizing this is using a number line, whereby if you tilt your head to your left, the positive numbers will be on your right and the bottom numbers will be on your left, right? But then for now, I'm just going to use the elevator as an analogy, right? Now, let's get into it. 7x plus 9x, what is it? You imagine yourself as if you are starting from the ground floor and then you go 7 floors up, all right? And then currently you're on floor 7. You carry on by moving 9 floors further again, which is 9 floors. But then we are pointing in the same direction. So whenever you're pointing in the same direction, you just have to add all these things because we are facing the same direction. That's why they are called directed numbers, because they have a direction and they have their sizes. Now, 7 plus 9, that is 16. But don't forget we are putting an x in front as well. So that is 16x. Now, let's solve the next problem. So the next problem that we have, it is 7 minus 9. So 7 minus 9, it means you have to go 7 floors up from the ground floor, right? Now, currently you're on the 7th floor. Instead of going up, you are going to move 9 floors down because of this minus 9. You are going to go down 9 floors down. But now we need to observe. If you check carefully, the downward movement has a bigger size, such that it dominates the upward movement. Now, when that is the case, you end up landing on the negative side or below the ground floor. Whenever you're below the ground floor, you're on the negative side. And since these actions are opposing each other, you need to find the difference. Now you are no longer adding. So 9 minus 7 is 2. We have minus 2x since we'll be on the negative side. Now let's solve problem 3. Now with the problem 3, it's almost similar, but then you find out why it's a bit different. Now here you start by going 7 floors down because it's minus 7. You go 7 floors down. And then you go 9 floors up. But then 9, remember, it's a bigger size. It's a bigger number. So it dominates. We have 9. But then we observe that the upward movement is dominating the downward movement, and these actions are opposing each other. So the difference is 9 minus 7 is 2, but we will be on the positive side because we will be above the ground level. So the answer in this case, it is 2x. So don't forget the x because it's common. Now we solve minus 7x minus 9x. Now solving that, what we need to have is that we first go down 7 floors down, and then we go 9 floors down as well from the 7th floor. So the 7th floor that I'm referring to, it is like basement, like where you park the cars or something of that sort. Now, since we are facing the same direction, it is 7 plus 9, which is 16. But we are on the negative side since we are below the ground floor. Now that is minus 16x. So that is what we can conclude. Now we go to the multiplication rules. Whenever we have a positive and a positive sign, the outcome will be a positive. Whenever you have a negative and a negative, the outcome will also be a positive. So what is the logic that we can deduce from there? Whenever you are multiplying the same sign, the positive sign is going to dominate. So minus and minus will always be a positive. But whenever you are multiplying different signs, the negative sign now will dominate. Like plus times minus, minus will dominate. Minus times plus, minus will also dominate now. So here we are saying 7 times 9 is 63. But this is a case whereby there's a plus there and a plus there. So that is 63. And then 7 times 9 is also 63, right? But then this is a case of a minus and a minus, which will lead to a plus. So instead of writing plus 63, we just leave it as 63. Now we have 7 times minus 9. Here we have a plus and a minus. Whenever we have a plus and a minus, minus will dominate. So this will just be minus 63. Here we have a minus and a plus. So minus 7 times 9. So 7 times 9 is 63. But this is a case of a minus and a plus. So which will be minus 63. Right? So we are done with the directed numbers with a bit of some algebra. Now we move to the laws of indices. And I'm not going to cover all of them, but parts of them. Then maybe we'll continue with the others later. Now, with the laws of indices, we can start by saying we have a to the power of m times a to the power of n. What is it that we observe? We observe that we have the same base. So whenever you have the same base, you are going to add the powers. So that is the first law. We are going to say a m plus n. That is the first. Maybe I can say it's law 1. Alright? Whenever you have the same base, you can add the powers. Now maybe let's do an example so that it can make sense. We can say, for example, 2 to the power of 3 times 2 to the power of 2. Here our base is 2 and our power we have 3 and 2. Now this is the same thing as writing 2 to the power of 3 plus 2, which is 2 to the power of 5. But then if you put in your calculator 2 to the power of 5, what are you going to get? So let's put in the calculator 2 to the power of 5. We are going to get 32. Now, let's say you did not know about these laws of indices. You are just going to do it manually. If you are going to do it manually, you are going to say 2 to the power of 3 is what? You are going to try and check what is 2 to the power of 3. So let me just 2 to the power of 3. That is 8, which is 2 times 2 times 2 is 8, right? And then 2 to the power of 2, which is 2 times 2, it's 4, all right? And then 8 times 4 will give you 32, meaning that the manual way and this other approach is still giving the same solution. Now we go to the second law. The second law, we are saying a to the power of m times a to the power of, instead of times we are going to divide. So we are saying a to the power of m divided by a to the power of n is equals to a to the power of m minus n. So what we are saying, whenever you have the same base and you are dividing, you subtract the powers. Let's take an example. We can take off 2 to the power of 3 divided by 2 to the power of 2. Here we are saying we have the same base and we are dividing. So that is the same thing as 2 to the power of 3 minus 2, which is 2 to the power of 1. And you should note that 2 to the power of 1 is just the same thing as 2. So that is our answer. If we're going to do it manually, we're going to say that 2 to the power of 3, we got it as 8 last time, right? Divided by 2 to the power of 2, it's 4. Now, what is 8 divided by 4? 8 divided by 4 is just 2. So it means it's still going to give you the same solution. Now, let's go to the third one. So here maybe I can call it, this one is law 2. And then let's go to the law 3. So for law 3, I'm going to say a to the power of m, and then I put a bracket, and then I put an n here. This is the same thing as saying a to the power of mn. But then also a to the power of mn is the same thing as a to the power of m times n is the same thing. That is another thing. If they say mn, they are just saying m times n. So that's another thing that you need to remember. And then maybe we can touch on an example so that it can be clear. Let me just clear at the top so that I can just touch an example there. Now, for this one, the example, I'm going to write it at the top. Here we have that, for example, 2 to the power of 3, and then we put a 2 outside. According to the law, we are going to say 2 to the power. So whenever you have a bracket and we have 2 powers at the top, you can multiply them together to become 1. So using that law, we can say 3 times 2 is 6. Now let's go and double check what is 2 times 2 to the power of 6. 2 to the power of 6, that is 64. Here we have 64. If we were to do it manually, we're going to say 2 to the power of 3, like last time we got it to be 8, right? And then 8 squared is 8 times 8. 8 times 8, which is also just 64. So meaning that this rule also holds. So you should just remember it, which is rule 3. And then rule 4. So let's make it neater and then let's start again so that it becomes more presentable. Now, for rule number 4, I'm going to say a to the power of minus m is equals to 1 over a to the power of m. Now, with this rule, what we're just saying is that, for example, 2 to the power of minus 3 is the same thing as 1 over 2 to the power of 3. So that is a rule that you just need to remember. And remember, 2 to the power of 3, we said this, which is just 2 times 2 times 2, it's 8, right? So here we have 1 over 8. This one is kind of hard to visualize, but if we were to do it manually, you are going to put 2 and you say to the power of minus 3 to see what you would get. So we would say 2 to the power of minus 3. What would we get? We would get 1 over 8, which is what you would get by saying 1 over or 1 divided by 2 to the power of 3. So this rule holds. And then the last one is a to the power of 0 is equals to 1. So anything raised to the power of 0 will give you 1. Let's say, for example, 5 divided by 5. We already know that 5 divided by 5 is what? It's 1. But using those rules that we know is that whenever you have the same base and you are, this one also is the same thing as to the power of 1 to the power of 1. And you are dividing, is the same thing as 5 to the power of 1 minus 1. And then, which is 5 to the power of 1 minus 1, it's 0. So 5 to the power of 0 will be 1. So anything raised to the power of 0 will give you a 1. Now let's just double check as we finalize. So if you say like 56 to the power of 0, you always be guaranteed to have 1. So that is it. Thank you so much for listening.